The next technique that we're going to look at for factoring polynomials is a technique called grouping. Now, if you just watched the last video, then you were working with greatest common factor. And you might be looking at finding the greatest common factor, and I'm going to go back and do just a little bit of review. You might look for the GCF of a binomial. Say you had 2x plus 18y. Common factor, the GCF is 2, and that leaves you with x plus 9y. You might be looking for greatest common factor with 3xy minus 8. Nope. Well, how about 18? X squared plus 27, x to the third, y to the fifth. All right. If you look at all these, the common factor is 3. They all have an x to low power, but they do not all have a y. So you would factor out a 3x. And remember, factoring it out means really dividing by it, but you don't throw it away. That would leave you with y minus 6x plus 9x squared y to the fifth. And I'm sorry about that getting so crowded. My point in this is, when you're working with greatest common factor, it doesn't matter if you have a binomial or a trinomial or something bigger. If there's something in common to all terms, you factor it out. Now, the technique that we're going to look at in this lesson is called grouping. Grouping is used primarily when you have 4 terms. There's not a GCF to all of them, but if you could break them into groups, you might see a common factor. All right, so this is best done by jumping right in. Let's take a look at some problems. The first one, I have x to the third plus 6x squared plus 2x plus 12. Please notice, if you look at all of the terms, they do not all share a common factor. These 3 do have 2, but this one doesn't. These 3 have x, but this one doesn't. So there is not a GCF for all of these. But I have 1, 2, 3, 4 terms, and I notice that if I look at this as a group and this as a group, look just at the first group. Yes, those have a GCF. Look just at the second group. Those have a GCF. So I'm going to work on this problem almost in pieces. Let's look at the first group. If this were missing and we looked only up here, we would see a common x, in fact, a common x squared. So I could factor out x squared out of this group, which means divide it out. That looks a little bit. All right. That's going to leave me with a single x up front plus 6. All right, now I'm through with this group for just a minute. I look at the next group. These 2 terms have a common 2. Because this term is positive, I would factor out a common positive, write it down, 2. It turns out that whatever this sign is in front of this term, that's the sign that's going straight down. If I factor a 2 out of this group, means divide those by 2, that'll leave me with x plus 6. You're going to find that the problems in this lesson are rigged to be factorable by this technique, which means that when you break it into 2 groups, you identify the common factor in the first group, take it out, common factor in the second group, take it out, you're going to be left with what's called a common binomial factor. Now think for just a minute. If you had x squared times a plus 2 times a, and I said, could you factor that? You'd say, oh yes, I see an a. Let me take it out in front, and then if you divided each of these by a, you'd be left with the x squared plus 2. All right, keep that in mind. Let's look over here. I see a common binomial of x plus 6. I'll factor it out, which means sort of yanking it out in the front. And what will be left? Well, if I took this factor out, I'd be left with an x squared for the first group. What would I be left with here? I'd be left with the 2. Sometimes I nickname these terms, which build the second factor, as the leftovers. When you factor x plus 6 out, you end up with x squared plus 2 as leftovers. Let's see if we can get more comfortable with this. The next one, I have 4x plus 12 plus xy plus 3y. No common factor to all 4 terms, which means that I then just go ahead and try a grouping technique. What's in common in the first group? Hopefully you see a 4. 4 goes in there x times, and 4 goes into 12 3 times. I'm going to bring down this sign of a plus. What's in common? I see a y. If you divide y into each of these, you will end up with an x, a plus sign, and a 3. Because these problems are rigged, you're going to have a common binomial factor, so let's grab it, write it in front, x plus 3, that's my common binomial. And what's the leftover factor? It is it is 4 plus y. And those are what I call the leftovers. And here are your factors. If you were to multiply x plus 3 times y plus 4 using FOIL or the distributive property, you would end up with these 4 terms. All right, let's look at another one. I have 15x to the third minus 9x squared plus 20x minus 12. There's not a common factor to all of them. So, since there are 4 terms, I'll break it into 2 groups of 2. In the first group, what's in common? Well, let's see. 3 goes into both of those. X is in both of them, and I take the low power of x to the second. If it helps you, still go ahead and write that down underneath that you're dividing. That's going to give you 5x for the first term minus 3, and those x's divide out. Next group, common factor, it's going to be positive. 4 goes into both of those. 4 goes into the first one, 5x times. 4 goes into the second one, minus 3 times. Well, here's my common binomial. I grab it, I write it out in front. What's the leftover factor? 3x squared and plus 4. Those are my factors. All right, let's see what else we've got. We've got a few more. I've got 7m to the third plus 2mn plus 7m squared plus 2n. All right, in the first group, I did make an m with an extra hump, but there we go. All right, there's not a common factor to all the terms, so I will do my groups of 2. In the first group, there is a common factor of m, and that's all. So if I divide m into those, that'll give me 7m squared plus 2n. In the second group, 7m squared plus 2n, they don't have a common factor. So all I can do is put a 1 in front of that. All right, so that's what I do when I have 2 terms that don't seem to have any, or don't have anything in common. But like I told you, these problems are rigged so that there will be a common binomial. The common binomial is 7m squared plus 2n. The leftover factors are m from right here, and then this is critical that you don't drop it, plus a 1. These are factors. It is the product of these. All right, so that example showed us what to do when you don't seem to have a common factor in one of the groups. All right, the last one. I have 6x squared minus 12xy minus 7x plus 14y. I have 4 terms. They don't seem to have something in common to all of them, so instead I will break them into 2 groups of 2. In the first group, you see a common factor of 6 and an x. All right, you're going to divide 6x into each of those. That'll leave you with x minus a 2y. The second group, most people immediately see a common factor of 7. But do you remember our discussion earlier? If the leading term of a group is negative, then the common factor you factor out is a negative. In this case, a negative 7. Okay, so this sign is always going to be down here. So you're going to divide each of these by negative 7. Negative divided by negative is positive, so that's positive x. Positive divided by negative is negative 2y. But once again, it all works out great. The common binomial is x minus 2y, and the leftover factor is made up of 6x minus 7. So this problem showed you what to do when the leading term in the second group is negative. All right, so now you work on some of those.